Welcome, everyone, to this next installment of my organ technology series. This is the first part of the Rodgers 33E, a new theater organ that I acquired recently. Getting my hands on this thing was quite an interesting process. A friend of mine in Sacramento, we were talking about other organ projects and work we might be doing. And then he said, I've got two 33Es. Do you want one? And I said, well, that depends on what kind of deal you want to make me. Once I got my act together, went up, picked it up. We got it home. It spent a couple of nights on the truck while I figured out how to get 600 pounds of organ console off the truck and into the shop. Long story short, we finally got it all taken care of. It's in the shop now. We'll be taking a look at that in just a second. Before we get going on this, we might want to talk briefly about the history of Rodgers and the building of theater organs. So, the first Rodgers theater organ was introduced in 1963. It was a Model 320, and it was called the Trio. And that basic console and specification remained in production until 1984, under three different model numbers and several different model titles. So we started with the 320 Trio. The year later, the 322 Trio Deluxe was introduced. Then came the 321 Trio. And then there was the late model 321 Trio, followed by the 321 Trio A and the 321 Trio BC. Various periods of production: 63, 68, 69, 77, 78 to 84. Some of the serial number information on these models is a little sketchy, at least on the technician's site. But doing a little math and a little deduction, obviously Rodgers built more than 1,000 of the Trio units. Very popular organ, and I played one back in the day, and I can see why. It was an extremely well thought out, absolutely as compact as it could possibly be, and still be a full feature theater organ. Now, one of the things about the Trio that maybe didn't make it appeal to everyone who wanted a theater organ was the fact that in order to get that console skinnied down just as much as they possibly could, the pedal board was a little smaller than normal. It still had 32 notes, it was still radiating, it was still concave, but it was not to AGO specifications. So in 1966, the 33E came out. This made the console just a skosh bigger so that it would accommodate a proper AGO specification pedal board. And with the extra room, they put a few more features on it, but it was still intended to be primarily an instrument for the home. And that's the instrument that I got a hold of. I have a fun history with the 33E. When I was a hockey game organist back in the day, the Selland Arena owned and still owns a Rodgers 33E, set up with, at that time, a massive external audio system so that it could be, sort of project into a 10,000 seat arena. Now, my first experience with Rodgers theater organs were in the form of their later models. Starting in 1971 and going to 1981, Rodgers introduced their biggest theater organ, the 340 Century. That instrument was a much bigger, more elaborate console, and really kind of pushed the limits of what you would put into a home. But it was a very complete, very wonderful theater organ. According to the serial number information, a total of 82 of those instruments were built. The other instrument that was in about the same era, between 1974 and 84, was the 333 Olympic. And this was, just about the same size as the 33E, had a few more features on it. The 33E was actually replaced with the 327 Marquis, And that was in production from 73 to 77, and only 65 of those units were built. By 1984, Rodgers was out of the theater organ business. They were continuing to build classic organs. They had moved on to their McCasco system, but it would be the 1990s before Rodgers would completely convert over to digital, and they would build their only digital theater organ, the 360. Not a wildly popular unit, but they did sell 47 of those. I don't have serial number information on that, and I don't have information as to how long it was in production. I know that it was in production in the early to mid 90s. Rodgers has not built a theater organ since. There were a few custom theater organs along the way. Rodgers Jenkins himself had a big fancy custom theater organ for his home, and there were a couple of others. And my friend Dave got a hold of a unit, an instrument called the 36F or something. I don't rightly recall, but they only built 2 of them, and it was kind of an experiment that didn't really go into production. But at any rate, let's go out into the shop and take a quick look at the 33E and what is going to be the first problem I have to take care of. Okay, so here she is. This is my Rodgers 33E. I kind of wish it wasn't in the white, but you know what, that's okay. The really cool thing that'll be really good with these videos is that I also got a complete set of schematics, and unlike the technical website, these are nice and clear and everything, so I can really see them well. So, as one would expect with anything that is 50 years old, brought it in the house, and of course there's going to be a few issues. So, first off, I don't know if this will come through really clear, but when you turn it on, there is a hideous amount of hum. Now, hum in an audio system, especially an older audio system, some of it can kind of be normal if it's just in the background and underneath the sound enough. It's not really anything to worry about. But this is really excessive, and so that's the first thing we're going to have to do to repair this old organ, is to get rid of that excessive hum. So what could be causing that? Well, there's a whole bunch of stuff that could be going on there, and that all has to do with the audio path. So shortly we'll go back to the desk and we'll take a look at the audio path and how we might approach this situation. Okay, I'll slip the microphone out of the way here. So, what does our audio path in the Rodgers 33E consist of? Well, we start with our tone generator. That continues through our filter circuits. We want to do FLT. Yeah, that'll work. And then from there, they go out to the expression module. And we're going to take a look at the actual expression module. From the expression shoe, well, we kind of do an interesting thing. We go over here, and we're going to end up on our output panel. Call that the OP. But in between, we take a loop through the accessories. Alright, so how does this all work? Well, our tone generator, of course, is the oscillators. They make a tone, and then in between here, of course, we have our keying and gating circuits. Then we end up with those tones going into the filters, which shape the raw tone of the oscillator into something that sounds like a pipe organ. Then we go through the expression module. The 33E carries all of those signals through an accessory panel, and the way this works, this adds reverb, This allows for a stereo input and output. You can hook a tape deck directly up to the machine. You can also, it accommodates a headphone jack and, of course, the spring reverb tank. I'm not going to use any of this, so that might be something we could get rid of. After we get to our output module, what happens here, our signal loops through here. In the output modules where we have all of our jacks and plugs for the external amplifiers, and then we go over to our speakers. Okay. Now when we're trying to hunt down some kind of audio hum problem, in most cases there's nothing going on in the speaker that's going to cause that unless we're dealing with a Leslie speaker. We do have a Leslie speaker, but it's not producing excessive hum. So that's probably okay, but there are motors and things. There's also certain types of speakers that don't use a permanent magnet. Instead, they use two electromagnets. You have to have a special amplifier to that. Those can be problematic. Get back to our amplifiers. Now, here's where we could be having some issues. If the power supplies on the amplifiers are giving us trouble, that's going to insert some hum. Well, I've already swapped amps around and swapped cables and checked cables and done all of that. I'm fairly confident that we don't have a hum problem either on the amplifiers or the cables extending to the amplifiers. Our output panel is where we could be having some issues. Now, let's think about what's going on here. We have our tone generator, then we have to go through the filters, then we have to go through the expression, and then we have to go through the accessories, and then we have to go through the output. Every time you do something with your signal, it gets weaker. So there has to be an amplifier to boost it back up. So there's amplifiers here, there's amplifiers here, there's amplifiers here, there's amplifiers here, and there's amplifiers here, along with relays and switching equipment. So when we get back into the console, we have all kinds of opportunities for some type of audio hum to be developed. Now let's go back outside, out to the shop, and we'll take another look at the back side of the console, and we'll get a physical look at these items, and I'll talk a little bit about how they might be able to cause some problems and how we might solve that. Okay, so I turned the console around and we're looking at the backside. So the first rack is the solo rack, and what we have here are the main oscillators, the keying circuits, and the filters for all the various voices that come off of those oscillators. This system is very much like what I've shown before with the Schober and the Devtronic stuff, where you have an oscillator set creating the tone. The keying circuits route that tone over to the filters, and then the filters send an audio signal out. This is quite a bit more sophisticated than either the Schober or the Devtronic system, and that's why it takes up so much more room. But that's the first rack. And of course, as we go through this series looking at this organ, we're going to take a closer look at all of this stuff and how it works. And we pull this out and we get to the second rack, which is the tibia rack. Now, in any oscillator-driven organ, the oscillators are either always on and gated, or they're keyed, just like a pipe valve would be keyed. And in the case of oscillators that are only doing a singular task, that works much more like a pipe organ. So on the first rack, the oscillators are in charge of several voices. So we have to gate the sound because the oscillators are always running. Gate the sound to the various, you might have different keyboards, different pitches going to the same or different filters. And like I said, we'll take a closer look at how that all works. But here, this is only doing the tibia. Now the tibia is unified across all of the organ, and so you have to have these relay switches, just like you would have on a pipe organ, and they work pretty much the same way. You press the key. If this stop is on, then the keying voltage is routed to that particular group of oscillators within the whole set, and you get the correct pitch coming out. The next rack is the Celeste Rack. And again, just like the tibia rack, the Celeste stop is only doing a singular task. So these are keyed just the same way that the tibia oscillators are keyed. Then when we get past this, we finally get to what I was showing you in the block diagram. Okay. So our oscillators make their sound, the keying circuits send that sound to the filters, and then we have an audio output that we would recognize. It's kind of like any other audio output like you'd have off your turntable or your MP3 player. And in this case, there are 3 audio outputs. There's the main, the tibia, and the brass. And so the main and the brass both come from the solo rack, and you just have the voices split up to 2 channels, one on each side. The tibia oscillators, the Celeste oscillators get mixed into the main. The tibia oscillators go to that other channel. Those 3 outputs then go to, here it is, the expression module. And this controls the loudness like we talked about from these shoes here. Then, after it's gone through here, it goes, here's the output side, and those go back all the way around over to here, our output chassis. But before any signal goes to the output chassis, it's first routed all the way back through this accessory loop. And that's this plug here. And so our 3 circuits go over here, and this is a mixer, but it's also a preamp, and that runs the spring reverb tank. And then over on the front of the console is the accessory panel for the stereo in and out and the headphones. And this is all stuff, the spring reverb, the headphone jack, those are all things that I'm not going to use. So that's kind of the first thing we're going to try, is let's just get that accessory out of the way. If there's a problem there, then I'm kind of done, because I don't need the accessory panel. If that's where our hum is coming from, then there's no need to fix it. Now, to bypass this, it's a little more complicated than just taking out this plug. You have to put jumper wires in there so that the signal, as it comes in, can then go on to the regular outputs. Now, the regular outputs have both the audio output and the voltage for the relay. The Leslie output not only has the relay and the audio, it also carries the 110 volts to run the motors in the Leslie speaker. That's definitely a suspicious problem right there, although most of our hum's coming from the other side. But I may, spruce up this audio system overall, and we'll take a look when I get to that. But the bottom line is that once the audio has gone through the expression module, from there I can bypass this, at least the audio portion of the output chassis, and just use it for the relay circuits to run and turn on and off the amplifiers and run the Leslie speaker. I'm not going to be using the accessory panel, so there's no need to have this as part of this big long audio loop. So there's 2 areas that I can eliminate for potential audio problems. And if that is where the problem is, then, I can maybe fix this stuff later on down the road or just not worry about it. Now, of course, we're going to get back almost somehow or another, we're going to get back to this main power supply. Now, this ultimately could be the source of the excessive hum. I think that, in most cases, if the main power supply is the source of excessive audio hum, well, you're going to hear it throughout the instrument, right? Not just on two channels. So, but still, this is 50 years old, and it's got these cardboard tube capacitors on it. This thing needs a rebuild. So, this is kind of a for sure thing. I'm going to have to rebuild this power supply just because. It's either giving out or it's going to give out, one of the two. So that, we might as well just go ahead and do it. Not only rebuild this, but when I was on the Rodgers technical site looking for information about this organ and its components, years and years ago, they made up a kit for improving this power supply. Right now, it is a straight, unregulated, linear power supply, but they have instructions, a circuit diagram, list of parts for making it a fully regulated linear power supply. And, I can get all those components. They're what's called new old stock, but I can get them, and we can upgrade this here power supply and know for sure that that's not causing a problem. So as you can see, dealing with a 50-year-old piece of electronics is kind of going to be an interesting journey here. For sure, I'm going to be rebuilding that the main power supply, and I'll be doing something with that long audio path. I haven't quite settled on what all is going to happen there, but come on back next time and see what happens there. There's several interesting possibilities, and I'm sure you'll enjoy what we're doing here with the Rodgers 33E. Thanks for joining me today. We'll see you next time.